Hi, in this question, I would like to solve three other important SAT-like math questions that their ideas often appear in the SAT test. So for example, question number 4, you have to calculate the arithmetic mean of a group of numbers. This is the main idea of the question. So they're asking to find the average or the arithmetic mean age of a group of 15 teachers. So we call this N, the number of teachers. And their age average is 40 years. So we'll call this A dot M to refer to arithmetic mean. If 6 additional teachers are added to the group, then the average age of the 21 teachers is 44 years. This is the after the addition. What is the average age of the 6 additional teachers? So I would like to solve this in details to explain the ideas and the background of it. First of all, what's arithmetic mean? So let's just do a quick review. Okay, so there's always a key that you need to use to solve this question. So arithmetic means. So arithmetic means sometimes they call it average. So of n values, let's call them A1, A2, A3 up to AN, is calculated using the following formula. So we will call this arithmetic means A dot M bracket N. So these are the N values, and this is equal to, so the sum of the N values divided by N. Another way to express this in more compact form is 1 over N times the sum of the N values using the sum expression or the sum symbol. So this is called the sum of all AIs from I equal to 1 to N. So we will use this compact form in this example. Now see how it makes our life easier. So let's go back to the question. The question says that if I have 15 teachers with age A1, A2, so the first teacher age, second teacher age, A3 up to A15, then it is given that the arithmetic mean of those 15 values is equal to 1 over 15 times the sum I equal to 1 to 15 AI, and the average mean is given by 40. So this here is equal to 40. So in this case, we have 40 equal to 1 over 15 times the sum I equal to 1 to 15 AI. So how do I now proceed? Now if you multiply this by 15, multiply 15 in both sides, we can get rid of the 15 here, and then we will have just that the sum from I equal to 1 to 15 of AI equal to 600. So we will need this later on. Now they say that if we add another 6 to the 15, then, so for example, if you take this, copy it, and then they say if you add another 6 teachers and with their ages, so you will have A16, A17 up to A21, then it's given that their mean arithmetic mean is now 44. So according to this given, we have that the average mean of the 21 teachers is equal to 1 over 21 sum I equal to 1 to 21 of AI. The arithmetic mean is 44 as given, equal to 1 over 21 times the sum of I equal to 1 to 21 times AI. So we can multiply this by 21, multiply this by 21, and in this case we can get rid of the 21 with 21, and then we will have that this 44 times 21 is given by 924 equal to the sum of I equal to 21 to 21 of AI. So that's another thing, we need that. So now they're asking us to find what is the arithmetic mean of those new 6. The arithmetic mean of the ages of those 6 teachers. So these only. So the arithmetic mean is, according to the definition, 1 over 6 times the sum I equal to 16 to 21 of AI. So we need to find only this component. How do we do that? From here, you can see that we can break up this summation I equal to 21, 1 to 21 AI can be broken into 2 parts. I equal to 1 to 16 of AI, sorry, to 15, plus the sum I equal to 16 to 21 of AI. Now easily we can plug in these values. The average, or this number, is 924 according to this, equal to this equal to 600 plus the sum I equal to 16 to 21 of AI. Therefore, if I take this to the other side, we will have the sum I equal to 16 to 24 of AI 21 is equal to 924 minus 600, which is 324. So you take this number and plug this here, so that we get 1/6 times 324. And how do we do this without a calculator? I can give you a trick. This is just 300 plus 24. So 300 divided by 6 gives me 50. 24 divided by 6 give me 4. So the final answer is 54. And that's it. Now let's move to question 5. This is an algebraic question which says that if you have a function f defined like this, f of x equal to x squared plus 18, if a is a positive integer or a positive number, if a is a positive number such that this condition applies, f of 2a equal to 3f of a, what is the value of a? So here is a important trick that I'd like to introduce and use. So the first thing you do is, in this kind of type of functions or this type of questions, you need to replace x by an open bracket. Okay, so let's replace x in this formula. Every x that appears in this equation, replace it by a bracket. So we will have f of, and let's put the bracket, equal to, so there's an x here, plus by a bracket, square plus 18. So if the bracket is x, f of x equal to x squared plus 18. Now let's find what's f of 2a. This one looks like. So this happens if we replace the bracket by 2a. Okay, then you replace every bracket on the other side of the equation by 2a, so that will be equal to this. And what's 2a squared? So there is a rule, remember, if you have one of the power properties, a times b all to the power of m, you can distribute this as a to the m times b to the m. So here we have 2 squared times a squared plus 18, and the answer will be 4a squared plus 18 equal to 3f of a. So what's f of a? F of a, just replace the bracket by a, and this will be equal to a squared plus 18. So it is given that f of 2a equal to 3f of a, and we need to solve for a. So we have 4a squared plus 18 equal to a squared plus 18. So this is here and that's here. So and of course this is f of a and multiplied by 3. So that would be 4a squared plus 18 equal to 3a squared. And here there's a trick. If I don't have to use the calculator, then I will keep this as 3 times 18. I don't have to perform the multiplication. Now we'll see why. So we need to now collect like terms. You can take this to the other side, and you can take this to this side and change the sign. So this will be 4a squared minus 3a squared equal to 3 times 18 minus 18. 18 by itself is just 1 times 18. So now this we have 4a squared minus 3a squared is just 1a squared, which is a squared, equal to 3 times 18 times 1 times 18. It's 2 times 18. So you can take 18 as a factor. So that will be 18 as a factor, and then you have 3 minus 1, so which is 2 times 18. And then if you continue, you have a squared equal to 36. So now taking the square root, we have to be careful. So if I take the square root, then you need to put the plus and minus. This is very, very important that many students they tend to forget. Okay, so please pay attention to this plus minus. So in this case we have root a squared is a equal to plus minus 6. So we have two solutions. So we have a equal to either minus 6 or a equal to 6. But in the original question, it says that a is a positive number. So there's a condition on a. Therefore, this is not accepted. And that's the final answer. Now let's do the final question. Question 6. A tech company bought a number of computers for its employees. So we have 6 computers costing $1,600 each. So let's create a table. So here we have the number of computers and the cost in dollar per computer. So the number of computers, we have first 6 computers for $1,600 each computer, and we have 4 computers costing $1,200, and we have Y computers costing $900, where Y is positive and odd integer. So there's a condition that this is a positive odd integer. For example, 3, 5, 7, 9, etc. So they're asking if the median price, so the median for all the computers purchased by the company was $1,200. What is the greatest possible value of Y? So how do we find that? So first we're talking about median. So what is the median in statistics? The median of n values, let's call them x1, x2, x3 up to xn. So suppose that these n values, they are already sorted from smallest to largest. Okay, then the median depends on n. If n is odd, then, for example, x1, x2, x3, x4, x5, suppose I have x values, then the median is the middle value. So in this case, we can say that the median equal to x n plus 1 divided by 2. However, if n is even, for example, x1, x2, x3, x4, x5, x6, then the median is just the average value of the two middle points. Or the two middle values. Okay, so in this case, the median is equal to x n divided by 2 plus x n divided by 2 plus 1. Okay, so in this case, how do we know the value n? Is it odd or even? So let's look here. Here we have six values of 1600, 4 values of 1200, and y values of 900. So the total number of computers n is equal to 6 plus 4 plus y, 6 plus 4 plus y, which is equal to 10 plus y. Now, it's given in the question that y is an odd integer. Added to it 10, which is an even integer. So, and we know from arithmetic, if you add even integer to an odd integer, then the resulting value is an odd integer. So n is an odd integer, the total value for sure. In this case, we have case number 1. This is the first case, and that's the second case. So case 1, when n is odd, then we have the median is given by xn plus 1 plus 2. So now remember, for the values, for the median, to find the median, we have to sort all the data. We have to sort all the prices from smallest to largest. So we have to sort first the 900s. We have y 900s, we have 4 1200s, and we have 6 1600s. So we have y 900, 900, 900, dot, 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 900, and here we have y values. And then right after it, we have the 1,200 computers, $1,200. And how many of them we have? 4. So we have 4 values. And then we have 6 values of 1,600 computers. So we have 6 values. So we need to find the largest odd number such that the largest value of y such that the median is 1,200. So if the median should be 1,200, then we know that this value should be the median, which corresponds to the value xn plus 1 divided by 2. And we know that the first value of the 1,200 is also equal to x y plus 1. So it has a position of y plus 1. So if this is the median, then we know that the value here is x sub n plus 1 over 2, the position. And at the same time, it corresponds to the y plus 1 value, xy plus 1. Because here this is x1, this is x2, this is xy, and this is xy plus 1. So in this case, the value of n plus 1 divided by 2 must be greater than y. So that in this case, we have that the median is at 1,200. Okay, so that's basically the condition for the median to be 1,200. So now we need to find the largest y. But we know that n is given by 10 plus y. So if n is equal to 10 plus y, so here we have 10 plus y plus 1 divided by 2 is greater than y. Now let's solve for y. The first thing we do is you multiply by 2 both sides, you multiply by 2 both sides of the inequality, so we can cancel the 2. And also we have 10 plus 1 is 11. So we will have y plus 11 is greater than 2y. So now you take the y to the other side, collecting terms. Then we will have 11 is greater than 2y minus y. So in this case, we have 11 is less than y. So that's basically the inequality. Now the question says, what is the largest possible value of y, where y is the odd integer? So what's the largest possible y? What's the largest? What's the greatest? Odd integer y less than 11. and the solution is y equal to 9. So 9 is the largest possible integer less than 11. And that's it.